Welcome to the Ex Terra Podcast. The Ex Terra mission is to explore and discuss the business of space and its effect on the national and global economy, as well as life on Earth. How does what happens in space affect your life every day? That's what we're exploring on the Ex Terra website, as well as on this podcast. My guest is Lisa Kuo, Vice President of Strategic Sales for Ramon.Space, which builds space-resilient computing systems that change the way software is written, applied, and processed in space. Lisa, welcome to the podcast.
Thank you so much for having me, Tom.
It's my pleasure. Let's just kind of jump right into it here and talk about space computing a little bit. How does that differ from terrestrial-based computing?
That is a really good question, and sorry about the convoluted answer, but I look at that question as there's two elements to it. The computing itself, how does computing in space different than computing in terrestrial? There really shouldn't be any difference. We all need computing. You need to process data. You need to do something with data. You need to move data. You need to store data. That should be the same, whether you're on terrestrial or in space. The part that is different, however, is how does the computers differ in space versus terrestrial? So the computers in space are a little bit different, well, more than a little bit different, very different, because of the space environment. First of all, there's no air. And second of all, there's the whole sun, and the whole no sun issue makes it really, really hot and sometimes really, really cold. Usually your terrestrial computer doesn't have to go through that kind of extreme hot and cold environment. So when you build a computer for space, you have to take account of that. And then on top of that, there's the whole entire cosmic rays. There's a radiation environment involved, which we don't have to deal with that on Earth either. So your computer have to be designed specifically for that kind of space environment, such that you can do the same kind of computing that you do on Earth.
So if space is such a harsh environment, why do computing in space at all? Why not just use a data center that's on the ground?
Well, that is also a really good question. I'm going to use a story to answer that question, right? Because
Sure.
I think about that question all the time. But why do I need computing in space? This is, maybe a long time ago, and I'm not going to say how many years ago, because that will definitely, age me. But long time ago, I remember taking photos on my little camera, and I don't know if the photo that I took was good or bad, until a couple of days later, I go get it developed. No, my mom gets it developed. I was too young to remember how to get it developed. Yeah, until it gets developed and I see the photo and it's like, crap, my eyes were closed. Or, oh, crap, the sun was reflecting on my glasses and I can't see my eyes and all of that. Can I take another picture? No, I can't, because the time is already gone. The people that I'm with they're already gone. So I cannot recapture the moment. But I didn't know that at the time it was a bad photo. So that is exactly why you need to do computing in space. Because, one example of the space satellites that we're seeing is our Earth observation satellites. They take pictures of the Earth, right? So you take pictures and you don't know if it's a good picture until it's being sent to Earth and somebody develops it. And then you look at a picture and say, oh, crap, that was just covered by cloud. I didn't really get the picture of the things I was tracking. Can I send a command and say, hey, take a picture again? No, the time has passed, right? So you need, quote unquote, somebody to say, oh, yeah, that was a good photo. That was not a good photo. Take it again while the object is still in the view. It's a very, very simple example. There's a lot of gazillion other type of examples that I can use on explaining why you need computing in space. But this is, really, really close to my heart because I take a lot of really bad pictures.
A long time ago in a galaxy far away.
That's right.
Talk a little bit, Lisa, if you would, about your background.
Of course, I am a space lifer, is what they call me. I have been fascinated with space since I first visited Kennedy Space Center. So there's that. Ever since my dad took me to Kennedy Space Center, I'm like, I am going to do one of those things. Whatever the rocket, satellite, space, I always wanted to be a space person. And here I am. I have been working in the space industry for more than 20-something years. I have been doing satellites. I'm super duper fascinated with how satellites work and how satellites actually impact our life. My mom always asks me, "Oh, so you're doing satellites? How does that impact me?" Right? So how does you making satellite have anything to do with my daily living? And I have to come up with like stories every single time she asks me that question. Like, "Oh, mom, you're paying gas at this really remote gas station. Guess how you're paying for it with your credit card? It is because you have satellite connections. That is, checking your validity of your credit card and making authorization that you can buy this gas, right?" So it's been a really fascinating topic for me for my whole entire life. And I am just really, really happy to continue to be in the space industry, especially in this time when there's a lot of new space, so-called a new space company, and doing a lot more really innovative and really cool things that we have never thought possible before.
It's interesting that you mentioned the way satellites and space affects people's lives, because most people, I don't think, really have a good grasp as to how much of what happens in their everyday life has some kind of connection to space. And it's getting more so every day, from the cell phones or the GPS in the car to, as you said, the credit card transfers. Everything seems to have a space connection these days.
Absolutely. I know there was an attempt, well, for my background, I do communication satellite. I do communication satellites, so that is kind of my thing. There's last time, at least I think I have educated my mom good enough. When we went on a cruise in the ocean, she actually said, "Hey, you need to improve your satellite performance so I can get better internet connectivity when I'm cruising at sea." I'm like, I'm so proud of her.
The light bulb went on and she said, "Oh, here's how this affects me." Lisa, you talked about how harsh the space environment is for computers, the radiation, the power demands, the thermal issues. How do you work on overcoming those obstacles?
And if I tell you the secret of how we overcome those obstacles, then somebody will come into this office and kill me immediately. But
but just in general terms.
In general terms, so for us, our company, Ramon.Space, we are a really interesting company because if you look at the composition of our engineers, there are mostly computer engineers. They know how to design computers, right? So you have to really understand how all the components of a computer gets impacted by this kind of space environment. What does the temperature, big temperature range does to all your soldering or this kind of FPGAs or this ASICs, and you have to understand how that impacts every single element, and then you need to figure out how to mitigate for that, right? So it's not a silver bullet. It's understanding the root causes of how all of these environment impacts every single components on your computer systems, and being able to figure out how to mitigate for that. So it's an art.
And it then kind of follows almost automatically that everybody's had a computer breakdown. Everybody's had a computer crash. We also, and 99% of the time, we'd like to launch it into space when that happens. But if it's already there, it needs an update, it needs a reboot, or it needs some maintenance. How are those things handled in orbit?
That is the key point, right? Because when my computer crashes, I call my IT and say, "Fix my computer right now." But when your computer crashes into space, first of all, the satellite in space is not going to call my IT department and yell at the IT department. And second of all, the satellite needs to know that your computer is broken. So that is why artificial intelligence is really, really important. Having the smarts in space, which smart comes with computing as well. So you need to build the smarts in such that you know what's going on with your computer. And when you see the problem coming, you need to be able to okay, I will reboot myself, or I will switch to a redundant unit, right? You need to figure out all of these things yourself. And that's why, having the smarts, having the computing such that you can build in all of these smarts into your computer as well as the whole entire satellite is very, very important.
Talk a little bit more about your company, about Ramon.Space. And what kind of a client base do you have? How do people find you? And what can you do for the people that you work with?
That is really, really a good question. I mean, I don't know how people find me either. People seem to that they do.
There's nothing wrong with walk-in traffic, Lisa.
Well, actually, we do have a really good network of clients and past customers and past partners, if you will. And then there's a lot of word of mouth. And we also go to conferences and, educate people on the capabilities that we have, as well as, how building a smarter system that is launching into space is going to be a lot more cost effective for whatever mission that they have. So I think it's a combination of a lot of different things. We get a lot of word of mouth out there, and we also have a lot of network of people. But I think more importantly is people actually do seek us out. I do believe that people understand the importance of having more smarts into their space systems, and they're just actively seeking out companies that can solve their problems.
So your niche then, kind of in the new space industry, is just to provide these computing platforms for a variety of customers.
That's absolutely correct.
That's a pretty good summation, yeah.
That is pretty correct. We like to think that, for computing, there are three elements of computing. The first part is you collect data. So after you collect data, you store data, right? It has to store somewhere. And then after the second part is you store data and you process it. Because data itself is meaningless. You really need to know what the information that you gather from the data. So you process data, and after you process data, you have to send it to somewhere such that it's useful for somebody. So there's three components to it: the store, compute, and move data. This is all the things that we do. We solve all of these above data-related problems as smartly and as economically as possible, put it that way.
And does doing that in space present rather specific or unique advantages to companies over using a terrestrial network?
Absolutely. I mean, there are a lot of things that you can only do in space. And then if you are doing things in space, you should process and store in space. I mean, it's, there's a whole concept of edge computing and the edge data center. It makes a lot of sense, right? The edge doesn't have to be edge on Earth. Edge could be edge in space, right? I mean, everything that is, Tom, you're asking me a lot of questions about how is space versus terrestrial, but, if you think about it, computing is computing. It doesn't matter where you are, you always need computing, right? All the stuff that you do on Earth, you have to do it in space as well.
And the ones and zeros don't care where they are.
They don't care where they are.
I'm talking with Lisa Kuo, Vice President for Strategic Sales for Ramon.Space on the Ex Terra Podcast. Take a moment right now to click on subscribe to make sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Let's talk a little bit about SWaP-C and why that's important.
Absolutely. Very, very important. People usually talk about SWaP. For all of those who don't know what SWaP-C is, size, weight, and power. And the last element, C, is cost. So these four are size, weight, and power, and cost. Yes, four elements are very, very important when it comes to launching space missions, because as we know, satellite, you are limited in, how much a satellite can be, how big it can be. I mean, it's something that's floating in air. Well, actually, there's no air. There's something floating in space, so it can't be an infinite size. It cannot be an infinite weight and power. You are going to rely on the solar power to provide you power. So, your source of power is rather limited. So everything is limited. So you want to make it as small and light and power efficient as possible, such that you can launch this thing as cost efficiently as possible. And the last element is cost. Of course, one of the chief technologists at a past company used to tell me that, Lisa, anything can be solved with money, right? All of these problems that you presented, all of these size, weight, and power, you can make the world's smallest computer to launch in space and still, perform great for 20, 30 years with lots of money. But not everybody has lots of money. And that is the problem that we're trying to solve. how do you optimize for the swap at the right cost point such that more people can fulfill their space mission?
But when you talk about, and I keep reading about the advances of companies that are using what they call COTS, commercial off-the-shelf components. You, on the other hand, build your own processors and storage devices. What is the advantage to doing that as opposed to using stuff that you can buy down at used to be Radio Shack, I guess?
I know there's no real good analogy for Radio Shack, and I love that analogy, but that's unfortunate. But yeah, the biggest difference is because these COTS, commercial off the shelf, is really designed for Earth, right? They really should be called Earth commercial off the shelf product. They are designed for Earth, designed for Earth environment, the Earth temperature, the Earth, there's atmosphere, and then also on top of that, there are human that can be involved. So if this component is broken, you can always swap it out. I can go in physically and swap it out. But in space, you cannot do that. There's a harsh environment. But on top of that, you can't just be like, oh, that was broken, let me swap it out. You cannot do that, right? So everything that you launch in space needs to be smarter, needs to figure out that, okay, that is broken, let me quote unquote swap it out, right? Being able to do that autonomously. So that's why we're developing this thing called the Space Off-the-Shelf product that is things that are components and equipment that are specifically designed for that kind of environment. With that consideration, knowing that there is nobody who's going to be physically there to swap it out when some components are broke.
So that's interesting. So you're developing a line of products and processors and such that you would then sell to customers who basically take your components and put them in their own stuff?
That's absolutely correct. Yes, a lot of customers, like that approach. Of course, we have customers who will take our components and integrate it onto their own system and fly it. We also offer customers like more of a turnkey solution, if they will, only because we really, really know the space environment, and we also know how these computing systems behave in a space environment.
You've talked a lot about machine learning and AI. Is that really the future of space computing, or is it really not that simple?
It's not that simple. And then also, it's not the future of space. I do believe it's a future of the space. You cannot have more futures in space without machine learning and artificial intelligence, right? Everything that I've been talking about, having more smarts, because there's no human up there. The space environment is harsh. You need to be smarter about how do you fulfill your mission. How do you employ this, mechanism or this algorithm? You have to be smarter about everything, and you have to rely on machine learning and artificial intelligence to be the smart machine that we're going to launch in space.
Do you foresee, and we're going to talk a little bit more generally about kind of the future in just a moment, but do you foresee a time when here on Earth we have data centers, data processing centers, huge places with rooms full of computers? Is that going to be something that comes to space eventually? Just because of the better environment, and of course, we'll need to talk to the moon, we'll need to talk to Mars, et cetera, et cetera, et cetera.
I love that topic, by the way. This is something that I talk to a lot of customers all the time. Actually, we have a debate. On one hand, I think there's a lot of good benefits about having data center in space. Because number one, if you look at the cost of building a data center on Earth, the biggest cost usually is, number one, is real estate, right? Because real estate costs money because it's big, and then number two is power because they need a lot of cooling, right? So these two are the biggest cost drivers for any kind of big data center on Earth. If you look in space, well, first of all, real estate is free, so there's that. And then number two, the power comes from solar. So you solve your two biggest cost drivers if you have data center in space. So there's the benefit of having data center in space, but there's the downside of having data center in space is, number one, it's a floating thing. So you can't keep on building this ginormous data center. You have to have, each satellite you're going to be restricted with swap that we talked about earlier, that you're going to be restricted on your size, width, and power. So you can't have like this super ginormous data center that's gonna, power the whole entire countries, or I mean, United States, data into the data center in space. So I don't believe there's gonna be these ginormous data center that is going to come into space. However, I do believe that there is a need for data center in space. Again, because of this whole entire edge computing concept, you always need an edge data center. All the data you collect in space, there is no reason that you have to transfer all the way back to Earth and process and do all of that. If you can just put a data center, like a mini edge data center in space, to store locally and you access locally, and you can do a lot of data fusion or processing locally. There's a lot of benefits of having these kind of edge data center in space.
So you foresee that being more of a bunch of, for lack of a better term, networked satellites together, as opposed to something in a big habitat like is being planned by so many companies. And the other thing is, obviously, the real estate is free, but getting there is kind of expensive.
Exactly. That's why the swap comes into play, right? I mean, the getting there, they charge you by the pound, if you will. So that's why the swap is really important. If one day, getting there, the charge the launch by the pound becomes a lot cheaper, then maybe you can have a lot bigger data center in space. But at this time being, and for the foreseeable future, I don't think it's going to come down as cheap as, trucking from, Texas to California, put it that way, right? So probably not. But I would love to see a lot of different types of edge data centers, and I would love to see each of these, discrete satellites becoming mini data center, and they can interconnect with each other to become like a big network of edge data centers. I also know that there are companies and individuals thinking about building big data centers on, like Mars or somewhere else where real estate is still free.
But getting there is still the issue.
Very expensive. But once you get there, real estate is free.
Well, and you would think that they would want to have their computing power there, because particularly when you get as far out as Mars, then there's the time that it takes to transfer the data between the Earth and Mars. So they really need to have something that's in situ that they can use to solve their problems.
Absolutely, absolutely. That is why I do believe that it's not one solution that is going to be like, it's not the one ring that rules them all. It's bunch of these little network solution, as well as some big ones and the small satellites, and the big space station might be hosting, as a data center as well. So we're going to see more and more of these kind of aggregation of data processing center inside and outside of space. That's what I believe we're going to see in the future.
So one thing more, Lisa, look out, if you would, over the next 10 to 15 years in the area of space commerce, and tell us what you see.
We are going to see more and more companies, trying to go towards something space off the shelf. I do believe that there's companies who's trying to do commercial off the shelf and realizing that, okay, it doesn't quite work, but we are getting closer, right? So I think we're going to see more and more companies developing these so-called space off-the-shelf components that are not custom tailored for a specific mission, but it's like a product. It's a product-based design. We're going to see a lot more commercial companies, build it, and they will come kind of mentality, the whole new space. I think we're going to see more and more of those. And we're going to see a lot of, even the government mission will embrace this kind of mentality and this kind of mission.
With the kind of exponential increases in computing power that we see pretty much on an annual basis, how is that going to affect what it is that you're doing, and how is that going to affect the entire space computing industry?
I think, let's first talk about the space computing industry. I think this is going to be a really exciting time. We would really, really love to see more Earth-like computing in space. And, as the computing capability on Earth gets exponentially better, we would love to see space catching up a lot sooner, a lot faster, right? Such that it gets to, my where the utopia of computing is computing, and you get the same kind of computing capability wherever you are, even in space, even in deep space, right? So I do believe that we are going to see that. And how does that impact us? That just means that all of the systems that we are building today, it has to be upgradable. It has to be like, you have to think about how the computers on Earth are operating and how they are being used and utilized. And you have to keep that in mind and thinking in the future that this is how people are going to use all these computing systems in space. We have to design to that. We have to keep on refining and make sure that our computing system is really the computing system we built for space really looks like the computing system on Earth.
And that to go back to something you talked about earlier, since there's not somebody who can go and swap out a component, as the latest and greatest processor comes online, how do you fight the not the redundancy, but the there's a word that I'm looking for, the obsolescence issue that will obviously come up at some point?
Yeah, absolutely. So that's why another reason why we are really focused on trying to make everything as software based as possible, because software you can always upload, right? So the hardware, there's a limitation on how long a hardware lives, but you try to pick the components that live the longest, and then you also try to make it as space environment friendly as possible, but you really put a lot more focus on the software, because software is upgradable and you try to make your system as upgradable as possible. This is one thing that we are really, really focused on to make sure that we can address all of these obsolescence related issues.
Lisa, we are out of time. Thank you so much for joining me on the Ex Terra podcast today.
Thank you so much for having me, Tom. It's been a pleasure and a wonderful conversation.
That's going to do it for this edition of the Ex Terra podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click on subscribe so that you don't miss an episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.